So far, we've looked at the difference between relational database management systems and other forms of database management in a very abstract way. In this movie, we're going to take a look at the reality of how this works and how our databases are structured. We're just going to be looking at the absolute basics here. We'll get into more details as we progress through this course. Here is one of the most basic units of a database. That is a table. This whole thing is known as a table, and the table's name is groups. Within the table, data is stored according to different kinds of data types, such as we may have a numeric data type or an alphanumeric data type. And what we want is for each record within the table to be similar so that all entries can be treated in a similar way. This is why we've split the table into columns. This is a column. The column's name is ID, and within MySQL our way of referring to the ID column of the groups table is groups.id. But never mind the technicalities for now. We're just looking at the general concepts. Here's another column. All the data within the table is stored within a column, and the column name is up the top there, name, groups.name to be precise. And this column stores the name of some of my favorite bands. We're going to use this table in conjunction with another table to access information about my music collection. A very simple database application. These are known as rows. Now, different database management systems will have different jargon connected with them. A long time ago, columns were known as fields and rows were known as records. For the sake of consistency, all the way through this course, I'm going to be calling them columns and rows. A row is a distinct unit of data. So each row is an entry within our table. Now let's take a look at the other table that we're going to be using in our hypothetical database application. This table is the songs table and is set up in a very similar way to the groups table. It has a unique ID column, it has the song title column, and it has another column called group, and we'll explain the reason for this in a second. Let's get these to the same size, and you'll notice that the numbers within the group column match up to the numbers in the ID column of the groups table. This is a way of forming a relationship between the songs table and the groups table. This allows us to avoid storing information more than once. So for instance, Still Number One, My Philosophy and Sound of the Police are all tracks by Boogie Down Productions, but there's no need for us to store the name of the group 3 times, or however many times we have songs within the songs table. That is redundant and can cause all kinds of errors, as we saw in the last movie with the misspelling of the name. And furthermore, if we realized that we had misspelt Boogie Down Productions, or we wanted to change that piece of data for whatever reason, all we'd have to do under this system would be to change the name in the groups table, and then when we came to pull data out about the songs, the group column would refer us to the entry in the groups table, and essentially the data would be corrected for all the songs in effect. This kind of relationship we're looking at here between the songs and the groups tables is known as a one-to-many relationship. This is how we write it in, if we were to draw up an official database diagram. This is not in any way well-formed database diagram. It's simply a simple way of representing some data. But n to 1 or 1 to n meaning indefinite number and 1 meaning only one entry. So in this case, each one group may produce many songs, but songs are only written by one group. Of course, there are limitations to this model, and if I was really applying this to my music collection, I'd find that there are a lot of collaborative tracks which would require me to use a more complex relationship known as a many-to-many relationship. However, for the sake of our example, this is a simple one-to-many relationship which links these two tables.